10 kilobytes a second. That's nothing for people on broadband or universities, but it's a whole lot for a guy in Namibia who doesn't have a good network connection otherwise. And they don't have to be EXA connections. They can just be internal relays. They relay from the guy in Thailand to them, to the rest of the Tor network. So the idea is we've got a lot of different users who will make a connection, a bridge, from all the users who are blocked from the main Tor network so they can get to the Tor network. And to do that, we need a separate set of directory authorities. We need a bridge authority that keeps track of all the different bridges out there so we can be able to give them to the right people. This is a little bit tricky because if we just use the same directory authority code, then you go to the bridge authority and you say, hey, can you tell me every bridge out there? And it says, yeah, here's the list. That would be really bad because then China should go to the authority and say, who are the ones I should block? So a little fix can fix that. The basic idea is if you already know about a bridge, if you know about its identity key, you can go to the bridge authority and say, I need an updated version of the server descriptor for this guy. Tell me about where he is now, what his keys are now, what his exit policy and rate limiting and so on are right now. So if you know about him, you can get a fresh version describing all the properties of him. But if you don't know about his identity key, there's no way to look him up. So yes, the bridge authority might have 80,000 people, but you can go there to learn updates about the ones you already know. You can't learn all of them. And another key point is that the bridges should publish their new descriptors using Tor. Otherwise, China should go to the bridge authority and watch all the people making encrypted connections to it and say, that's a bridge, that's a bridge, that's a bridge. But if you use Tor, we have an anonymity system already. Why not use it? One of the other key points here is once you have a working bridge, once the guy in China has some way to get to the Tor network and the bridge authorities, he's all set. He just uses that. He can get to the whole rest of the internet. He can get to the bridge authorities to get a few more bridges. So once you have one, you're in business. You've got a whole connection to the rest of the internet. So what we've done here is we've changed it from how do we keep China from learning 800 IP addresses, how do we keep China from learning the main Tor directory, to now we have 50,000 IP addresses, how do we give them to the good guys in China without letting the bad guys learn all of them? So far, so good? Great. Okay, so another big thing that we have to fix, and I'm going to skip over this for the most part, is hiding Tor's network fingerprint. Right now, if you watch what happens in a TCP dump when you do a Tor handshake, you will find the string Tor in the handshake, because we try to be polite and follow the RFCs and specify what sort of certificates we're going to provide. Maybe that was a really bad idea with respect to making Tor hard to filter. But that's one of the big things that we need to fix. Another piece is that right now when you're doing directory connections, some of those happen with HTTP in plain text. They're signed, so there's no integrity issue, but you can actually see some guy asks for the web page /tor/ blah, blah, blah. And I think I noticed a firewall product that came out recently that has an IDS signature for somebody fetching a web page that starts with /tor/. So that certainly we can solve. And the easy answer for that is that we should push everything through the Tor TLS connections, not only the Tor traffic, but also the directory requests. And we need to pick a good default port. Right now, some of the defaults are port 9001, which looks very odd for people who are just web browsing otherwise. If we have most of the bridges open up port 443 by default, we'll be doing better. And we need to make it look like a more ordinary, I'm connecting to my bank, what's the problem, sort of handshake, which gets complex when you start looking at timing fingerprints. If the adversary has been paying attention to the recent work on detecting encrypted BitTorrent, then they might start to say, hey, wait a minute, I don't care if it's encrypted, I can still see that you're sending a lot of bytes this way and sending a lot of bytes this way, and no bank does that. You're not browsing at your bank, you're doing something else with this encrypted connection. So it really depends how much the adversary is going to pay attention. And that goes back to the earlier statement of he doesn't have that much computation available for every single connection. Once we have 100 million people in China who are making encrypted connections back and forth, nobody's going to look at every single one of them and say, are you actually talking to a bank? Are you actually talking to eBay, E-Trade, all the other encrypted connections they might make? Okay, so those are the first two things we need to fix. We need to figure out how to do bridges and bridge authorities, and we need to figure out how to fix the TLS handshake. And the third one is discovery. How do we actually let poor Alice in China figure out what bridges she can use? So the easy answer is Tor is very modular. So we've separated the relay component from the discovery component. We can use any discovery component we like. Great, we're all set. Except we don't have a perfect discovery component. Even though it's modular, we still don't know the best answer. And hopefully we can help to solve that today and the next couple of days. So the first issue is bootstrapping. How does Alice find her first bridge? How does she get out and learn something that she can connect with? And the answer for that is the firewall is not perfect. She's already getting out and reading various websites. She's just doing it in a very inconvenient way. I hear that people SMS each other, hey, I found a new open proxy, here it is. And then it works for a few days until somebody stops it, and then they send each other a new open proxy. There are people who connect to World of Warcraft, and they don't actually play the game, they just sit around chatting about new open proxies they found. Okay, great. And there are people who use Skype and other connections like that to get around the firewall. So they're doing it right now. The firewall is not perfect. There are a lot of people who have a friend who opens up SSH, and they just make a tunnel out and they're all set. So there are ways of doing this, and if you don't know how to, then hopefully your friend does, and you can make an initial connection and learn about a bridge at first. Okay, so how do we actually do this? There are a lot of different ways that we could do discovery, and I'm going to describe 5 or 6 different ways, and the idea isn't that we have to figure out which one's best and just use that one. We should deploy all of them and find out which one's best. So the first one is independent bridges with no central discovery. It's just like the circumventor and CGI proxy and other ones I talked about before. The idea is I know somebody in Germany or the US, and he's going to run a bridge for me, and I'm going to use that bridge. So hopefully I have a social network that extends outside of China. Otherwise, I can't use this approach. So hopefully I know the bridge's operator, or maybe a friend of mine does. The telling a friend idea has some pretty interesting incentives behind it, because if I know about a bridge and I tell my friend, if he screws up, if he gets it blocked, I can't use it anymore. So maybe I'll have to make some good decisions whether I want to tell my friend about it, because I want to stay connected too. And the other piece of that is that you're mapping your social network for the attacker. Let's say I tell all of my close friends who are other dissidents about it, and then the adversary learns about that bridge, and he watches who connects to it, and he says, oh, these 12 people are using that bridge. That's very interesting. I didn't know that those 12 people were friends. So we need to be careful about how we actually build that sort of thing. But once we've got that, that's the easy part. That's just, you use Tor, except you use a new hop before you get to the Tor network. The next step is families of bridges. The idea is Tor takes care of all this circuit building in the background, so why not have the nice guy in Ohio run 20 different bridges? Or maybe it's a consortium, it's a Linux users group in Toronto, and each of them runs a bridge, and they all put them into the same family, which means that that Alice in China can learn about all 20 of them at once. And that means that if 10 of them go away for a little while, or they turn their computers off, or they're on dynamic IP addresses and they get a new IP address, Alice isn't screwed. She still knows about some, and she can connect to the bridge authority and learn about the new locations for all the rest of them. And that way she can stay connected. As long as one of them is still up at any given time, she can learn about the new locations for all the rest of them. And all of this happens in the background. It's all automated. So hopefully we're in a lot better shape than systems like CGI Proxy, where you just say, hey, can you please run this on your Windows computer for me? And when you turn your Windows computer off, I'm screwed, and I have to either wait till you wake up and turn it on, or find another friend, or something like that. So far, so good? OK. So that's great, but what about bridges who don't know any users? Or what about users who don't know any people who can run bridges for them? So for that approach, we need some sort of public discovery system. We need some sort of system where I'm in China, I don't know anybody outside of China, but I still want to be able to get some bridges and make some connections to the Tor network and then to the rest of the internet. So the idea here is some people in Ohio are going to say, I really want to help out, but I don't know anybody in China, so put me into the public bridge pool. Let people know about me, and hopefully something good will happen. So we can break them up into different pools based on their identity key, which is what they generate when they become a Tor relay. And we want to break those into different distribution strategies. And the idea is each of these distribution strategies is going to have a different property that it tries to force the adversary to show. Maybe some of them are going to say, you spend a lot of time to attack this distribution strategy. Maybe other ones are going to say, you need to solve all these CAPTCHAs to attack this one. So the idea is to exercise a different scarce resource for each one of these. And this means an attacker might be able to attack some of them, but not very many attackers should be able to attack all of them. And I'll tell you more about that as I describe some. So the first one is a very simple one. We have maybe 100 bridges in that pool, and only 10 of them are available in a given hour. So if you ask for a bridge over the course of a given hour, it gives you one of those 10. In the next hour, it switches to a new group of 10, and it only gives you one of those. And in the next hour, it switches to a new group of 10. So if you want to learn all the bridges in that pool, you need to keep on asking for many hours in a row. So you have to care and pay somebody to stay up and keep asking all the time. So it's not foolproof. I hear that China can employ people to use the internet for long periods of time. But maybe some other attackers won't be willing to do that. Maybe the US corporation that says no Tor on our network won't hire another person to go figure out who all the bridges are that people can use. So there are a couple of helpful points. First of all, it'll help people to bootstrap until it is blocked, and it'll be blocked at different points in different attackers. And hopefully it'll be a start. It's not perfect, but it's an easy one to build initially. So another strategy is based on IP address. If you're coming from a certain network on the internet, then we give you this bridge address. If you're coming from over here, then we give you this bridge address. So if China wants to learn all the addresses in this pool, then they have to come from a lot of different places on the internet. And again, I hear that China has a lot of different places on the internet, so it isn't perfect, but they at least have to figure out how to make the connections from a lot of different places and actually do that over time. So it's not going to be perfect again, but it forces them to do a different exercise than they did for the first one. So far, so good? And then the third approach is combine them. Over a given hour, when you're coming from this place, give them this one. When you're coming from this place, give them this one, and so on. And then for the next hour, there's a new set, and they're distributed based on your IP address. So this means that not only do you have to have a lot of different networks that you control, but you also have to do the requests for many hours in a row or many days in a row, depending on how many volunteers we have. So it's a nice start. It's not going to be foolproof, but it will at least force people to continuously attack us. And the approach they do right now is they just pull down the directory and filter it all. So we're doing better. A fourth trick might be there's a project out there called Circumventor, and they run a mailing list. You show up and you say, can you add this Yahoo address to your mailing list? And then every 3 or 4 days, they send out a new set of 10 bridge addresses. And yes, China could sign up on the list also, but they don't react that quickly. So far, Circumventor sends out a new list every 3 or 4 days, because 3 or 4 days is about what it takes for China to block the ones that they sent out. Maybe we'll have to speed this up to every 1 or 2 days. Maybe it'll be every 6 hours. If we get to that point, it probably won't work so well. But certainly when we start, China isn't even going to care. They're not even going to know this is happening. So we'll see. It might work great. It might not work at all. And then a fifth strategy is you send us an email, and we send you a bridge address. That's all there is to it. And we don't answer more than once, so you have to create a new email address if you want a new answer. And we could require a CAPTCHA. You have to fill in the little letters that you see in this picture. And I don't have to write my own CAPTCHA code. I can just say it needs to be a Gmail address or a Yahoo address. And I'll let them take care of